You know very well the 4 types of roles that you see as part of every Hadoop cluster. What are those roles? Name node, or I mean you call them as roles or you call them as services. I think you might have noticed what is that we did as part of the cluster access. You remember what is that we did, Laden?
Yes.
Yes, got connected, and then 170. Yes. Um, I think you noticed this one very clearly even in the last couple of discussions. So on each node, we will have the roles that are being set up. I have my HDFS name node set up on my master one. I have given you that picture. I have given you that overview. What are the roles that we have as part of that? So where I have shown you that one, I have shown you that one. When you go over here, you can see, yes. So this is a big picture. I think you see on each node, what are the roles that are being set up? The same we are trying to discuss over here now. There are 4 types of roles in a basic Hadoop cluster. What are those roles? Of course, the fifth one also. That is your secondary name node. But in the contemporary clusters, if you see, with the advent of Zookeeper, your cluster itself is now highly available. As a result, I don't need to depend on my secondary name node. That is the reason why we see these 4 types of roles on any typical Hadoop cluster, even in the today's Hadoop landscape. Most machines in a cluster will perform 2 types of, two of these roles, functioning as both data node and task tracker. Most machines in your cluster will perform 2 of these roles. What are those 2 roles? Data node and a task tracker. Of course, the task tracker is just nothing but, what is the task tracker? What is a task tracker, Laden?
Is it resource manager?
No, it is node manager. Resource manager is your
node manager. Job tracker. Yeah. This is a node manager.
Yeah, you're right. Node manager. And typically because your job tracker and name node are being set up. I was telling the same thing from the beginning of our discussion. Hope you remember. For name node and job tracker, we require, what we require? High configured machines, because They are CPU and memory intensive, CPU and memory intensive process. So they require more resources. Whereas your data node and your task tracker, I mean your node manager, you can set up those things even on very normal configured machines. But still, in the most production clusters, you will be seeing these are the recommended specifications for data node or task trackers in a balanced Hadoop cluster. You got the point, balanced cluster, Ryden?
What would that mean?
But there is a in-depth meaning for the term called balanced cluster here. Here, the recommended specifications for data node or task tracker in a balanced Hadoop cluster. What do you mean by balanced Hadoop cluster? What do you mean by that? You have any idea, any clue on what you mean by balanced cluster?
So maybe some machines will be high performance, some will be low performance.
Yeah, one way that is right. I appreciate. One way that is right. I appreciate. But balanced cluster here, I mean specifically.
Or to share the role.
What is that?
Is that what you mean? Probably to share the roles, to balance the roles on, like, say, data node, name node, maybe install 2 more roles on one machine, and then having like a 3 or 4 or 5 services on each machine. Kind of balance the work of the server. Or you mean like a load balancer, or?
No, sorry.
Okay, then I don't know.
The theme of balanced cluster is something, because if you look closely, the cluster, I mean, either we'll be having a storage. What happened? Yeah. So if you look closely, either we'll be having storage or we'll be having processing. But interesting, when it comes to Hadoop, you have both storage and processing together, right? On the same node, on the same machine, you have storage and you also has got computing power. You have both storage and computing power on the same machine. Now imagine if the storage is more, whatever the reason, if the storage is more, I'm happy to store more and more data, But at the same level, if I'm not able to process, then my computing is going to be affected. In the beginning, we have seen big data is a problem statement. I think you remember those days with three V's. What are those? Volume, variety, and velocity. These two are being well addressed, but if this is not been addressed, then you are not giving an apt solution to the problem statement called big data. So your computing also should happen relatively fast. How you are able to store more data at the same time, you should be able to process more data quickly. Both should happen. More data storage, more efficient processing. Both. When both are being addressed at a decent level, then we call that to be a balanced cluster. That is the reason why the spec is being given here. 12 to 24, 12 to 24 uh, TB storage. 12 to 24. That is in the range of 1 to 4 hard disks. 1 to 4 hard drives, because even though you may be interested, you cannot keep on adding the hard drives onto the motherboard. The motherboard may not be able to support. You cannot keep on adding the hard drives. There should be a provision on the motherboard, right, Vladan? To add the hard drive. Vladan, you are there?
Yeah, can you hear me?
Yeah, I'm able to hear you. Yeah. I thought you were not
Okay.
there. Yeah.
No, I am.
So if you look closely, if you argue with me, Srinivas, if I have a configuration less than this, what is going to happen? Nothing. As I told you, we have this cluster now, whatever I'm trying to show you here. This has only 8 GB memory, and hardly 900 GB, roughly equivalent to 1 TB storage on each node. Still, the cluster is running for the past 10 months without a single shutdown. But in the production environment, we are going to keep the real big data, huge volume of data or bigger data sets. And when you submit a job and you wish the job to process your data and you expect the job to finish fast, then you require certain basic configuration to make up the things. That's the reason why we are talking about this. Two quad or hex or octa-core CPUs running at least 2 to 2.5 gigahertz. 64 to 512 GB of RAM. 10 gig, 10 gig, not 1 gig, 10 gig Ethernet, because I'm not sure whether you have gone through the MapReduce job execution or not. A MapReduce job, has the following life cycle. Life cycle. A MapReduce job has got the following life cycle. What is that? You have a mapper phase, then we have a combiner phase, then we have a partitioner phase, Then we have a shuffle and sort phase. And finally, we have a reducer phase. Your MapReduce job has got these many stages. These two will happen at a node level. Every node of the cluster where the blocks are present. It will happen on every node where the data for the given job is available. I think you see here, your mapper and combiner phase will happen at every node in the cluster where the data for the given job is located. If you have a cluster of 40 node, but you want to process a specific data set, the blocks for that given data set are located only on 6 nodes. Then your mapper and combiner activities will happen on those 6 nodes, not on all the nodes present in the cluster. Okay. Then we have a partitioner. This partitioner also runs on every node, but its job is only to decide. There is no processing activity involved during partitioning. No processing activity. What is going to be with the partitioner is, partitioner just decides which data should go to which node for further processing. That is all going to be decided by your partitioner. That physical transformation of the data from the nodes to the respective nodes for further processing is carried out by shuffle and sort phases or mechanisms. That is why the names shuffle. Why I'm discussing all these things is to make you to understand this small aspect called, I need a high-end Ethernet card because I expect the data transfer to happen from one node to the other node just like that at a lightning speed. To make that possible, I definitely need a high configured switch, Ethernet card, and the supporting infrastructure. Not just having the card, should have the ability to even transfer the data using your other devices, not just the Ethernet card. I also need the associated devices to work in sync with that configuration. All right. So these are the minimum things that you take into consideration while setting up of your data nodes. 12 to 24 hard drives, storage capacity, 12 to 24 TB storage capacity, 2 quad or hex or octo core CPUs depending on the availability of the hardware infrastructure and the cost that we are planning to spend it in setting up your Hadoop cluster. And then your RAM, 64 to 512 GB I'm talking here. Please try to understand, I'm talking about GB. 64 to 512 GB of RAM. 64 to 512 GB of RAM. And then you have a high-end Ethernet card. So these are the minimum things that are required. That is where I am talking about the sizing. The sizing. How you are going to size. The name node is responsible for coordinating. See here, if this word goes off, the entire meaning gets changed. Name node is responsible. Name node is responsible for coordinating data storage on the cluster and the job tracker for coordinating data processing. The standby name node should be co-located on the name node machine for clusters that will run on hardware identical to that of the name node. Cloudera recommends that customers purchase enterprise class machines for running the name node and job tracker. I think now you got the point. Cloudera recommends the customers to buy or to spend it on enterprise class hardware. Enterprise class hardware, I mean, what the hardware that we use for setting up of your enterprise data warehouses. EDW, enterprise data warehouses. So we expect name node and your job tracker to at least run on enterprise class machines because they are CPU and memory intensive devons or applications, right? With redundant power and enterprise grade disks in RAID 1 or 10 configurations. And you also see the name node will also require RAM directly proportional to the number of data blocks in the cluster. A good rule of thumb is to assume 1 GB of name node memory for every 1 million blocks stored in the distributed file system. For every 1 million blocks of data that is been on your storage, you require 1 GB of the name node main memory. I'm talking here, not your secondary memory um, where you store your data and the other stuff, right? 1 GB of name node memory for every 1 million blocks stored in the distributed file system. Distributed file system. We also recommend having high availability, that is called HA. We also recommend having high availability configured on both the name node and job tracker. You see here. This is the recommended specification for your name node and the job tracker. Okay. These are just to know. But other than this one, you can set up your Hadoop cluster on any hardware. That is what I was showing you. These machines are plain normal desktop machines on which we have set up the cluster here. Whatever you are seeing now, these are plain old normal desktops which you use as part of the educational institutions. You know very well what configuration will be there. Maybe around uh, 8 to 16 GB of RAM and probably 1 to 2 TB of storage, the normal Ethernet cards, and even you take your hard drive, maybe a TB or two, but not more than that. But still, we were able to set up the Hadoop cluster on this one and is running without a single shutdown for the last, I think, 8 to 10 months, right? There are some health issues that gets arised over a period of time. Those needs to be handled and needs to be taken care. The rest is yours. You got the point?
Yeah.
I've gathered from different sources to give you the understanding. For light processing, what is a configuration? For balanced compute, storage heavy configuration, and compute intensive configuration. I have given some details so that you understand. That is where we need to decide here, Vladen. It is not just blindly done. You need to have that understanding. What is the type of the cluster you want to set up? Is it the core goal for the storage or balance the compute or storage heavy or computing heavy, depending on the type of the cluster you are planning to set up. Slightly the things will get changed. That's where we have light processing, balanced compute, storage heavy, and compute intensive. So all been covered. All the context of your Hadoop needs are been covered. So depending on the type of the cluster you are planning to set up, you need to keep that configuration. All right.
Yep.
You can see these details even. I've given a small basic use cases. Um, you have a telecom company and you have established that you need 750 terabytes of storage space for its call detail record log files, CDR log files. A small use case been taken here so that you understand. See how you plan your cluster basically. Planning is essential, right? Are you getting my point, Laden? Planning is
Yes.
essential. How you plan the cluster. You should have some requirement in the mind, right? How the requirement is going to be. How the requirement is going to be.
Depends if you want a live processing or balance computing or
Yeah, that is what we have learned just before. But how you plan the cluster, you need to have the requirements like what amount of data you are planning to store currently
yeah.
and what is its growth rate, right?
Yep.
Say my current need is to store 750 terabytes of data and at what rate the data is growing. Maybe 2 TB per every month or a 4 TB per every month, whatever. You need to have that clarity in the mind. You need to have that clarity in the mind. What is the current storage need and the projected data accumulation? Based on that, you plan the cluster. That is one point. I'm not saying here first step, second step like that. That is one point to be considered. Second, how frequently you crunch this data or process this data and how fast you need to process this data. Based on that, you decide what is the computing power needed on every machine. And we try to balance these two things. And based on that, we decide what type of cluster we need to form. That is what we have learned just before. Are you getting my point?
Yes.
Suppose I have 500 TB of data, I mean CDR, call detail record log file, CDR log files. If the size of the CDR log files is around 500 TB, because that is the most useful and trending use case in the telecom industry. Processing the telecom data, call detail records, processing so that you get a lot of meaningful insights. If the replication factor is kept at 3, and my current storage need is 500 TB, then I need to have 1500 TB storage because I'm going with the replication factor 3. Every block is available at 2 more places in the same cluster. If the rack awareness is enabled, then it will make sure that all the 3 blocks, all the 3 copies of the same block are not being kept in the same rack. One block in one rack and the other 2 blocks in the other rack, so that we will not be facing the challenge, right? And what is a swap space that is needed? Why this swap space is needed? That is where I have explained you the MapReduce job phases here. I'll have a lot of mappers running. Let me also give you the clarity of and here we see about this. Yeah, that is good that we see MapReduce part, so that you will get, because a lot of things are linked with MapReduce. Until and unless you have that sound understanding of MapReduce, it's always going to be Greek and Latin for you. So this is the big picture, Latin. From RDBMS using Scoop, you get the data into HDFS. Your logs and all those stuff from sensors and all those different sources, you pull the data or you collect the data using Flume and get that into HDFS. And then you have your FTP or NAS using this Flume or directly into HDFS. Right? I think you see here.
Yes.
You have the recommendation server. You have the recommendation server where your web server is going to interact with the recommendation server based on the data that is present in your HDFS. Internally, you may be using the components like Hive or Pig to crunch the data and push the recommendations to the web server. But web server can either interact with your HBase directly or with your recommendation server set up on your HDFS cluster. When your Hadoop cluster, you can see that one here, this diagram. This is a big picture of your Hadoop cluster. Make sense? Now, going to this, you look at this very closely. Whatever been shown here, your input data is being sliced into uniform blocks, and those blocks are being pushed onto the different nodes following your options, what been set at the cluster level. If it is your rack awareness, if that is being opted or enabled, then it will make sure that all the 3 copies of the same block are not present in the same rack. 2 blocks in one rack and the other block in the other rack, so that even for any reason, if the rack is down, still the data is being made available. That was the intention there. Look at this one very closely. Madam, there is a lot of meaning hidden inside this slide. Please go through this one thoroughly. Please.
Okay.
How the data are finally coming? All the similar data that is where being shown in one color there. One color there. 1, 2, 4. What is being shown here? How that is being finally pushed to the reducer phase. And what is happening in between? Shuffle and sort phase. What is happening inside each node? Your mapper phase, your combiner phase, and your partitioner all happen at the node level. And your shuffle sort at the cluster level, reducer also at the cluster level. Got it?
Yes.
I know understanding just like that, seeing single diagram about MapReduce is not possible, but you need to go through this one constantly so that you understand. Now coming back to this discussion, swap space. Swap space. I mean, on every storage, I need swap space for the reason that is the one with which I am able to accommodate my MapReduce job execution, which is expected to be 25% at least, so that my processing will not be affected in any way. So to make all these things possible, suppose if your need is to store 500 TB of data, 500 into 3 is 1500 TB. There itself we have the replication factor of 3, and then what we have 25% of the space towards your swap space. Okay, so all put together, your 500 TB of actual need, we require a storage of 1875 terabytes of storage. 1875 terabytes. Number of slave nodes, number of racks, how they are needed, how they are needed to you based on what is that 500 TB of call detail record. Based on that, we are doing all these things. That is where I am saying, even tomorrow when you are facing the interview, you need to be confident. Until unless I come to know what is the requirement, I cannot tell what is the recommended configuration for your cluster. Clear? That is where I am trying to show you here a small and simple use case, so that the same can be applied at the prorate basis in any type of cluster we plan to set up, right? How many racks are needed and all that stuff. I'll share these things with you so that you can go through it. What is that? What is the plan needed?
Backup and disaster recovery.
Otherwise, see, Hadoop itself is the last option for us to store the data. This itself is the last option for us to store. From here also, if the data is gone, then the data is gone permanently in most cases. If the data is not available in the Hadoop cluster, think that it is not available anywhere. Right? That is where backup and disaster recovery plays an important role. Backup and disaster recovery. That is where it has been briefly mentioned here. But we have a separate subject called backup and disaster recovery. That time we talk only about that. Now, as a part of the other discussion also, we are talking about this. Read this one.
I read it.
right?
Yep.
Also look at this. This point.
Okay.
Right? These are the points that needs to be considered by us while working with the aspects. Right?
Yeah.
I think now what is that? Performance tuning, sizing, performance, and the configuration of your cluster. You see, most things that you come across here, they are, what is that? Say, for example, when it comes to tuning, memory tuning, or IO tuning, wherever you go, every time we come across one thing, that is, every time we come across the MapReduce job only. Rather undergoing the pain that about MapReduce each and every time, whenever we come across, if we study the MapReduce job life cycle, then our journey in understanding other things becomes more efficient. What do you say? Because you see, anywhere, when the map output is very large, intermediate data size should be reduced using various compression techniques. We don't know what is the output of a map job, map task as part of the MapReduce execution, what input it takes and what output it gives, then you never understand why the intermediate data size should be reduced using compression techniques. You never understand that one. That is why running a MapReduce job is essential. Though you are an admin, but still we need why this map output and why it is linked up with your compression. These things you come to know only when you have your map output very large, so that you apply those things. That is why understanding the life cycle of a MapReduce job is very, very important and crucial for all our learning process. You agree with me, Lauren?
Yes.
Tell me, what is a MapReduce job life cycle now?
It's a mapper, combiner, partitioner, shuffle and sort, and reducer.
Wonderful. I appreciate. So what is the importance of each phase, or what happens during each phase?
Mapper and combiner, they work at the node level.
What is that?
I said mapper and combiner.
Mm.
They work at the node level. So every node,
Yeah,
at the node
I
level,
agree. I
where
agree.
every node.
True. Where the blocks for the given data are present, on all those nodes, mapper and combiner will function. Even, of course, partitioner also, but partitioner will not do any physical processing. It will not touch the data or do anything on the data part, but they just guide which output should go to which reducer, which output of the mapper should go to which reducer. The output of the mapper is directly or indirectly being sent to reducer only. That is the one which actually gives you the final output of the MapReduce job. So now time has come where we must learn MapReduce job life cycle very in detail and see at least one or two jobs running on your Hadoop cluster in terms of MapReduce. Then we'll be more confident in working with the other aspects, right? So I don't want to take this concept forward without we understanding the MapReduce job life cycle. MapReduce job life cycle. I think you noticed here, Aladdin, tuning the number of mappers, writing a combiner, how you use the skewed joins, and what is speculative execution. So all these things comes under tuning. And without we understanding the life cycle of the MapReduce job, understanding these points is just like the theory, not more than that. Either you need to by heart or remember so that we apply the same thing again without any logical sense. Without any logical sense. When you come to the performance tuning, there also you come across a lot of the MapReduce stuff. But once storage is done, rest of all is the processing only, right? Storage will be done only one time or it is been set up constantly so that it keeps on pumping into your storage. But processing is something which needs to be initiated by you. And you definitely need to have the whole of control on it, right? So I advise you to go through the life cycle, MapReduce job life cycle, so that we can look into these aspects clearly and cleanly. Make sense?
Yes.
Now, how you go through the MapReduce job life cycle then? What are inputs needed for you? Take any typical document and study about MapReduce job life cycle, and because diagrams are the same, they are not going to be different. And each, what is the importance of each phase? What input each phase takes and what output, with a suitable example like what I'm going to show you now. You see here, are you getting the point?
Yes.
Like this kind of diagram is needed. Mapper, what input it is taking, what output it is giving. Combiner, what input it is taking, what output it is giving. Partitioner, and then we have shuffle sort and finally reducer. Right? Then it makes more sense to learn about performance tuning and other stuff at your cluster level. Right?
Yes.
Please go through that one, Laden, probably in the tomorrow's discussion.